So we're on the 9.2 notes. I think page 2. We're going to finish the 9.2 and then do 9.4 notes. I think we already did number 1 yesterday, correct? We're going to do number 2. Yesterday we talked about an acronym, which was SOHCAHTOA. What does S stand for? Sine, and O is opposite over hypotenuse. Cosine, dang it. C stands for cosine, which is adjacent over hypotenuse. T stands for tangent, which is opposite over adjacent. So, let's use it here. We got sine from angle C, so that is the perspective we're looking into the triangle from. So, what is the hypotenuse of this triangle? 40. What is the opposite? 32, and 24 is the adjacent. We want to use sine. So sine from angle C, you always have to write the angle you're coming from. Sine from angle C equals the opposite, which is 32, over the hypotenuse, which is 40. Can this be reduced?
Yes.
Yes. What are they both divisible by?
8. Oh, I meant 2.
They are divisible by 2, but then you can keep dividing it. It is divisible by 8. So if you do 2, you would do 2 again, and 2 again, and 2 again, and then you'd have the most reduced. Or you can divide by 8. Either way, you get 4/5. You would just keep dividing until it was as small as possible. All right. We did 3. We're doing 4, right? Cosine, how do you spell C? C-A-H. So from angle A, which is my hypotenuse? 41. What is my opposite?
15. We're on 3.
40. We did 3 yesterday, didn't we? Yeah. Okay. Opposite of angle A is 40, and adjacent is 9. All right. So cosine from angle A equals the adjacent, which is 9 over 41. Can this be reduced? It does not. How beautiful. And then the last 2, tangent from C. So from C, we're going to label the sides. Where's my hypotenuse? 34. And where's my opposite? And 16 is adjacent. Tangent is TOA. So what number is going to go on the top? 30. And on the bottom? 16. Does this reduce? Yes, to what? 15 over 8. Last tangent from X. What is my hypotenuse? 17. My opposite? 8. And then my adjacent is 15. So tangent is TOA. So what number goes on top? 8. And on the bottom? Does this reduce? No. All right, so we're on 9.4 notes. Now at the top, this is, again, another visual way to remember SOHCAHTOA. So S stands for sine, and it is what side over what side? Opposite over hypotenuse. So that's what you write into the little boxes. Give me a second to write mine in. Opposite over hypotenuse. All right, cosine is C. How do we spell C? A-H. Adjacent over hypotenuse. And then tangent is TOA, so it would be O over A, opposite over adjacent. Again, it's just another visual way to show you SOHCAHTOA. Okay? Below is just when you would use what. Because again, even though right now, this section is literally called the tangent ratio, so we're going to be using a trig ratio. Students struggle with figuring out when to use the Pythagorean theorem or when to use a trig ratio. Okay, so that's what this section is. You can fill this in. See how it says trigonometry? Trigonometry is the study of triangles. I'm actually going to show you some ways that this applies to real life on the next slide. But here, if a right triangle has a missing side, use the Pythagorean theorem. That is the fill in the blank. If a right triangle has a missing side, use the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. So all of these lowercase letters, they represent sides. The main point of this is you can only plug in sides into the Pythagorean theorem. You will only ever find sides in the Pythagorean theorem. You'll never find an angle. You'll never plug in an angle. It has nothing to do with angles. Only sides. So I would say use the Pythagorean theorem like 1 time out of 10. Whereas 9 times out of 10, you will use trig ratios. Okay, so second scenario. If a right triangle has given you 2 sides, you can find the missing angles using trig ratios. So if a right triangle has a missing side, has given you 2 sides, then you can find the missing angles using trig ratios. So key word is that you're finding angles and you're going to use trig ratios. We actually don't learn how to do this till 9.6, but it's there. We can use trig ratios to find angles. So if a right triangle has given you 2 sides, you can find the missing angles using trig ratios. You've actually been setting it up this whole time when you say sine of A equals 8 over 17 or whatever. This A represents an angle, and it's what's missing in this equation. So with 2 buttons, you learn how to find angle A, and I kind of showed you that yesterday. But we don't learn that till 9.6. Okay, but again, you use trig ratios. The last one we're going to use today, if you're given a side and an angle in a right triangle, you can find all the missing sides and angles using trig ratios. So again, anytime you're dealing with angles, it's going to be a trig ratio. So if a right triangle has given you a side and an angle, you can find all missing sides and angles using trig ratios. All right, so what is the point? Why are we doing this? There are a lot of jobs that use trigonometry. So like oceanographers, you can turn to the next page, but I'm still here. Oceanographers and marine biologists use trigonometry a lot with their sonars and sonography. You go way more into depth in Algebra 2 about what that looks like the graphs of sine and the graphs of cosine and all that jazz. We just learned the basics, but you use it there. You obviously use it in engineering. Do you know what civil engineering does? What does civil mean? Is what? Like city, yeah. So civil engineering is like the streets and the buildings and the bridges and all the things. They actually measure like what angles roads should be in so that cars can make an appropriate turn. Anyways, they make a crap ton of money. My friend is a civil engineer. Architects, surveyors. Surveyors are the ones on the side of the highway with like an orange tripod, and they're looking through it, and they're measuring like angles and pitches is what it's called. And then navigators, estimators also make a crap ton of money. A lot of things in construction obviously use trigonometry, but some others like robotics, roller coaster engineering, video games engineering. There actually used to be a section in Epcot, like at Disney, where they would talk about all of the calculus and trigonometry that is involved with Imagineering, which is how they like make roller coasters. And you used to be able to make your own roller coaster. That would have been a really cool road trip, or not road trip, but field trip for you guys, because that would have been educational. They took it away because I guess people aren't nerdy enough for it, but
That was my favorite.
yeah, see? You see it. You've been there. The other ones are just miscellaneous. You got mathematicians, obviously. My first year of teaching, my student like broke my heart because he was like, why are you a teacher when you could make $100,000 being a mathematician? It's because I love you. That's why I'm here. Radiologists, and then crime scene investigators. That's what this picture is of. So, if you look, can anybody guess what he's doing? I know it's kind of hard to see. What is it, Dorian? Okay, it's kind of a ruler. It's not, but it's... So, I thought you said bullet. So what happened is there was a shooting, and so they're measuring the trajectory of the bullet. They're measuring the angle. So, pretty cool. So you can measure how far away the person was. You can measure how high up the bullet is. There's a lot you can do with trigonometry and angles in crime scene investigation. A student here is in forensic. She does virtual learning lab, Miss Dix.
Maggie.
Yeah, so Maggie's in forensic science, I think it's called, and she does some trigonometry. So it's pretty cool how you can see it. So I think you'll like today's lesson. Yesterday was just the foundation. Now we actually are going to apply it. So 9.4 is about tangent ratios. So what's going to happen is we're going to review what's on your quiz, and then your book is just going to teach tangent ratios as if you don't know what a tangent ratio is. So we learned it yesterday, but we're just going to focus in on tangent ratios today. All right, so this is a similar quiz question. Find all the trig functions from the smallest acute angle. It did use the word function, but don't let that scare you. Function, ratio, it's all the same thing. You're going to find sine, cosine, and tangent. From the smallest acute angle. What do we notice about this triangle first? It's a right triangle. What else do we notice? It doesn't have a side. So how do I find that missing side? The Pythagorean theorem. A squared plus b squared equals c squared. These are all side lengths. We're missing a side length, so we're going to use the Pythagorean theorem. Which of these is going to be c? 29. Yep. 29. See, but now you got a fancy schmancy calculator. So 20 squared plus, we don't know, so we can call it x squared. 20 squared is 400 plus x squared equals 29 squared is 841. Subtract 400. 441, correct. And the square root of that, x equals 21. So what did we just find? The length of the other side, correct. So I'm going to fill that in. I am going to make this smaller. So it's out of my way. So now we're going to find all the trig ratios or functions, however you want to say it, from the smallest acute angle. So which of these is the shortest side? 20. So what angle is across from that? A. So we're going to be looking into this triangle from A. So we're finding sine from angle A, cosine from angle A, and tangent from angle A. So remember, you've always got to tell me what angle you're coming from, or your sentence does not make any sense. We're going to label our sides. Which of these is the hypotenuse? 29. And then which is the opposite? 20, and 21 is adjacent. All right, so sine is so. So what number is going to go on the top? 20. Is that what you said? Oh, over 29, I see. Sorry, I heard the number 22, and I was like, that's not even an option. Cosine is ca, so A goes on top, the adjacent, which is 21 over 29. None of these have been able to be reduced, so we're just leaving them. Tangent is TOA, so what number goes on top? 20, and then on the bottom, adjacent, which is 21. None of these can be reduced, so that's it. This is 2 questions on the quiz tomorrow. There's only 4, so 2. Okay? So, that part was from me. This is from your textbook. So now it's going to teach you tangent as if you've never learned tangent. On the homework tonight, the directions are slightly different. This says find tangent of S and tangent of R. Your homework says find the tangents of the acute angles in the right triangle. But this is a news flash to you. S and R are the acute angles. There's 3 angles in a triangle, right? There's S, T, and R. T is a right angle. So 180 minus 90 is 90, which means these 2 have to add up to 90. Therefore, they're both acute. So when your homework says find the measure of the acute angles, it's asking for these 2 angles, S and R, or whatever the letters are. Okay? So let's find tangent from S first. Yes, it spells tans. So from S, we're going to label the sides. Which of these is the hypotenuse? 82. Which of these is the opposite? 80, and then 18 is the adjacent. So we want to do TOA, which is opposite. So 80 over 18. TOA, opposite over adjacent. It says write each answer as a fraction and then as a decimal. So we do want to reduce this. What are 80 and 18 both divisible by? Just 2. 2. 81 is divisible by 9. It's okay. All right, and then it does say a decimal rounded to 4 decimal places. It is a beautiful number. If you have this in your scientific calculator, you hit S to D. It's above one of the yellow buttons, I think. How many of them are we going to write? We're going to write the 4 point, and then how many 4s after that? 4 of them. Wow, 4 again. What a time to be alive. 4 is a lucky number?
4 is like the weakest link.
That's hilarious. Yeah, I don't think anybody. It's like 4 and 6. Like, who picks those numbers as their favorite numbers?
I picked 6, and I always win.
You think so? 6 is the devil's number, so not a fan. It's okay. I'm just teasing you. We're gonna find tangent from R. So I'm gonna change the color to purple so you can kind of see. Is my hypotenuse gonna change? No. But my opposite will change. What's my opposite now? 18, and my adjacent is 80. So opposite is 18. Adjacent, we said, was 80. This reduces to 9 over 40, which is what decimal? 225. 0.225. You can put a 0 at the end if you so choose. You also don't have to. So we already knew how to do that. Now we're going to apply it, guys. We're going to find stuff. We're going to figure things out. Are we ready? Let's do it. So, in this section, it is obviously called the tangent ratio. So all of these are going to be tangent. But on your test, it won't tell you what trig ratio to find, or what trig ratio to use, sine, cosine, or tangent. So I'm going to teach this to you as if you don't know that this is the tangent ratio, and as if you don't know which one to use. So I'm going to have you write down 3 steps. I'm going to write them in the middle, and I would just write them in the middle as well. Step 1 is we're going to label the given sides. We're going to label the given sides as opposite, adjacent, and hypotenuse from the given angle. So step 1, we're going to label the given sides as opposite, adjacent, and hypotenuse from the given angle. So label the given sides as opposite, adjacent, and hypotenuse from the given angle. Step 2, we're going to set up a trig ratio. And step 3, we solve for x. So this is the process we're going to use on each of them, even though this section is literally called tangent. And so here's why you're going to use a trig ratio. You are given the measure of an angle, 61. You're given the measure of a side, 22. Can I plug an angle into the Pythagorean theorem? No, I can't. So I need to use a trig ratio. To figure out which one, step 1 says to label the given sides as opposite, adjacent, and hypotenuse from the given angle. So what angle did they give us in this first question? 61. So everything you label needs to come from the perspective of 61. What kind of side, these are my given sides, are x and 22. I don't give a flip about this blank side. I just don't. I care about these two. I want to find x. I know this is 22. What kind of side is 22 in comparison to 61? Opposite. And what kind of side is x? Adjacent. So the step 2 would be set up a trig ratio. At this point, you would have to decide which one. So, ka or toa. So in this one, you have the adjacent and the opposite. So which trig ratio is that? Toa, which is tangent. So we're going to say tangent. Normally we put a letter because we don't know the measure of the angle. But do we know the measure of this angle? Yes, we do. What is it? So tangent from 61 equals the opposite, which is 22, over the adjacent, which is x. So believe it or not, setting it up is not the hardest part. This is as hard as they come because a lot of students are like, well, I'm just going to multiply both sides by 22. But you can't, because would that cancel out this fraction over here? No, where would this 22 have to be in order to cancel out the fraction? It needs to be on the bottom. So do you believe in geometry that what you do to one side of an equation, you do to the other? We all agree? So here's what we're going to do. Everything in life is invisibly over the number 1. If you typed in tangent of 61, like we did before, we're not doing it right now, you know that this is worth like a decimal, right? This is a number. So every number in the world is invisibly over the number 1. I want to have 22 on the bottom and x on the top. I can do that by flipping the right side, but if I flip the right side, what do I have to do to the left side? I got to flip it. So 1 will then become the top, and tangent of 61 will be on the bottom. Are we all okay with the flipping here? Okay, well, you'll like it in a second. So now, what is happening to x? What's that 22 doing? It's being divided by 22. So what's the opposite of dividing by 22? Multiply by 22. So we're going to multiply both sides by 22. This is, again, one of those moments where you do not want to be passive in your education. You want to be typing things in. So take your scientific calculator. You are going to type in exactly what you see. So we are multiplying 22 times a fraction, times 1 over tangent of 61. So 22 times, you have a fraction button. If you're not familiar with the Casio, it looks like 2 squares on top of each other. You know where it is? Mm-hmm. Yeah, okay. So 1 over tangent of 61. Now before you type enter, if you already have, you probably have an error message. That is an error of you, not an error of the calculator. Hey, are you typing it into your calculator? Because I don't see your calculator in your hand. I guarantee you don't want to be missing out on this. So, do you see how it had an open parenthesis? You're going to have an error message if you have an open parenthesis in a fraction. So you have to close the parenthesis, and then you will not have an error message. Every year, someone during a quiz, Ms. Marshall, it's giving me an error message, and I'm going to say, sorry, boo-boo, I tried to tell you. Okay, so what did we get when we did 22 times 1 over tangent of 61? So we're rounding to the nearest tenth.
I think just type it on the first row.
You have to use the arrows.
The what?
The arrows? Give me a second. What is it? 12 point, yeah, but to the 10th. There's 1, 0, and 10, so there's 1 decimal place. Thank you. 12.2. It's okay. Did anybody not get 12.2? You want to make sure you know how to type things in. How did you do, Adriana? You get it? Dorian, I know you have a different calculator. You figured out how to do it in yours? Okay.
So is the whole thing 12.1947?
Possibly. Yeah. And then rounded, you do the 2. All right. That is the harder step because x was on the bottom instead of on the top. But sometimes, most of the time, it'll look like this next one. We have 56. We're going to label everything from the perspective of 56. What kind of side is x? Opposite, and 13 is adjacent. So which trig ratio are we going to use? Tangent from 56 equals the opposite, which is x, over the adjacent, which is 13. Do I need to flip this one? No. X is being divided by 13. What is the opposite of dividing by 13? Multiplying by 13. So you do not type in a fraction at all. You type 13 times tangent of 56. And we are still rounding to the 10th. What's it? 19.3. Wonderful. All right, we're doing one more together. It is a word problem, putting it in quotes. They gave you the picture. We're just describing it. You're measuring the height of a lamppost. You stand 40 inches from the base of the lamppost. So that is, you know what this is. You measure the angle of elevation. This is a term we'll talk about later. From the ground to the top of the lamppost to be 70 degrees. Find the height of the lamppost H. So you can do this without pulling out a measuring tape and measuring it. You can use trigonometry. So they gave us 70 degrees. What kind of sides were we also given? What kind of side is the H? Opposite. And what kind of side is 40? So which trig ratio are we going to use? Tangent from which angle? 70 equals the opposite, which is H, over the adjacent, which is 40. Do I need to flip this one? No, it's being divided by 40, so the opposite of that is multiplying both sides by 40. So you're not typing in a fraction at all. You just do 40 times tangent of 70. It does say round to the nearest inch. Yeah, so you get 109.9, right? So that rounds up to 110 inches.